Hello, Roel.
Hi.
All right.
I'm in, everyone.
Great. Well, thanks for joining us virtually. I'll just say a few quick words. Roel Dobbe is an assistant professor at TU Delft in technology policy. What is that? The full name is technology policy and management. I'm sure I'm missing.
Yes,
yes,
correct.
technology policy and management. And his work really is on really understanding the implications on society when we deploy and we integrate technology at different levels, not only in terms of individual usage, but what happens when it becomes part of our infrastructure, of our institutions, and it really blends with the fabric of our society and our everyday life. And he's been thinking very deeply about this for the many years that we know each other, and since well before then. He got his PhD at UC Berkeley, where we both got to have a lot of discussions about what it really means to define good behavior for these systems, and to say that they are reliable, or to talk about whether they are capturing our values in the design. And Roel, I will always have to thank for having really introduced me to a lot of literature on the matter that I was very much unaware of as somebody coming from this, let's say, purely technical perspective. And I think that what's great about this is that being trained as an engineer, sort of all the way from his undergraduate years, also at Delft, all the way to his PhD at Berkeley as an electrical and engineer and computer scientist, he has much of I would say, all of the technical background to understand, the tools that we use to think about safety, but he's always been looking at it from this combined and multidisciplinary perspective that incorporates value-sensitive design and thinking about the societal and ethical aspects. So much so that this is the direction that he's really become world-leading expert in, and he's been, right after his time at Berkeley, he was one of the, I think, founding postdoctoral scholars in the AI Now initiative at NYU, where he organized a workshop about the different kinds of vulnerabilities that we are beyond the purely technical ones. And anyway, I'll shut up now because I think we're here to hear what Roel has to share, but I'm very excited to have him contribute a view that I'm sure is going to be very, very interdisciplinary about what it means to truly have systems that are, as we've been saying, not just trusted, but actually trustworthy. With that, Roel, I'll pass it on to you. I don't know if I've missed anything terribly important.
Well, very quickly before we start, do you mind if we record your talk?
No problem, no problem.
Okay, thank you.
Let me just see if I can.
Yeah, maybe that's the best.
Okay, perfect.
That's the best way to.
Recording in progress.
Perfect. So, very good. And then I think what we'll probably do, well, you can let us know, Roel, if it's probably easier given the technological barrier of sorts if we try to save most questions until the end.
Yeah.
But if anyone has any burning questions, please. So, great. Whenever you're ready, take it away.
Can you see my slides?
Oh, we're seeing your speaker notes. I think you may want to do the switch. I think it's the button on the top left.
Let's see. Now you probably see them, right?
Yes, perfect.
Yep. Okay. And let me see if I can navigate my slides. Are they flipping?
Yep.
Yeah.
Yes.
Oh, perfect. Well, first of all, thanks everyone for joining this workshop. I'm sad that I couldn't come. I think many of you might imagine why that is if you're a professor who's trying to also really like ask a lot of critical questions about AI, and in the current world where there's lots of in current US context where there's lots of moving pieces, I've sort of decided that it's better to wait a little bit and see how things evolve. But I'm there with all of you, my friends and colleagues, in these very difficult times. That being said, thank you, Jaime, and the rest of the team, Andrea, for the kind invitation, and thank you for the very kind words. Also, Jaime, I'm again honored to join for this workshop, and I hope many good conversations will follow from it, from hopefully a bit inspired by the talk. My talk is titled "Algorithmic Harm and Safety Are Sociotechnical. What are our interventions?" And in this, I've given a similar kind of talk before, but it was a little bit high level, so now I'm trying to bring in more of the actual research we've done over the last years. And the thing that sort of jumped out for me looking at the workshop description was this question about, okay, how can society understand what type of assurances it should expect and demand from these technologies? That's a very big question. Let's see how far we get. So my background, I was actually a peer, started together with Jaime in Berkeley, the PhD trajectory in 2013. Had already been trained as a mechanical engineer, control systems engineer. Like Jaime and others in the lab, we started focusing more and more on how do you integrate machine learning into control systems, into safety critical systems. So that's always been a central theme for my research. And then Jaime already actually mentioned that, I've always been interested in policy questions, ethics of AI, the multidisciplinary need for multidisciplinary research, and also the translation between science and policy in society. Currently I'm heading the Sociotechnical AI Systems Lab. Today I'm trying to feature some work from a few of the lab members. It's grown a lot recently, so it's quite a challenge. But the cool thing is that in the Netherlands we have a very big AI consortia that are sort of by design interdisciplinary. These are AlgoSoc, which is a bit more leaning towards the social sciences, but also with some interdisciplinary engineers like myself. Hybrid intelligence, which is sort of the opposite, leaning more towards AI scholars, but also with some people doing more ethics and system science. And then we have a very big, it's called an innovation center, which is really a collection of more than 25 labs now, all with different societal partners. It started with corporate partners, but now there's also many public institutions that all have labs with like roughly 5 PhDs, and we're working within that context, we're working with one of the biggest energy utilities, distribution system operators, looking at the integration of algorithmic systems in operating the grid sort of locally. I won't really be talking about that, but if anyone is interested in that work, then at least you know. The TLDR of the talk is that safety and algorithmic harm are socio-technical. In essence, I would say so, and so are many values that are expressed through with AI and algorithms. But most AI governance efforts often sort of emerge as an add-on or an afterthought of the reasons for existing tools and applications. We need a deeper understanding of what in system science and also in safety science is called emergence. It means that values show us that the interventions to promote or protect are needed across social, technical, and institutional components. So safety is really something that expresses itself beyond the technical model or the software. But luckily, history is rich in concepts and methods to resurface and also to integrate. This is the story, I think, of my lab and most of the collaborations I'm in. And through integration, we built a socio-technical understanding of the safety problems in a new era, in a new domain that necessarily bridges the practical and the critical, the social and material, and the technical and political. So this is the outline of the talk. I think I won't get through all of it, but maybe you can ask me questions towards the end. Yeah, and so I'll just jump right in. So talking about gaps in AI governance. So I really quickly want to run through this because I can talk for hours, but this is sort of the basis for starting my lab. So now I've done my PhD in Berkeley with Jaime. I did a postdoc at the AI Now Institute, which was one of the first sort of multidisciplinary and also more critically oriented AI policy research institutes. Is now more of a think tank, but back then we were at NYU and we had postdocs, and I was one of the first. And I did that for a few years, and I started my professorship in the Department for Technology, the Faculty for Technology Policy and Management, coming in with sort of this understanding of the sort of emerging AI safety, AI governance space, which it's sort of like a sort of rough depiction where I say, well, there's lots of new issues, well, there's lots of new opportunities, but focusing on risk and how to deal with risk and also harm. You really saw a lot of reflexes from more, let's say, pure disciplines or communities. So this is where you saw a lot of very technical work on AI safety emerging. In ethics, you saw lots of initiatives in the public and private sphere, and in policy, you saw more and more instruments. Actually, the Netherlands, where I'm also originally from, tends to be a front runner when it comes to like digital policy. And so there were lots of new policy instruments. Like one example is the algorithm register. So making sure that governments and companies have a register where they sort of keep track of what are the algorithmic systems and tools that they're using. Back then, I sort of had these gaps laid out. So too much of a techno push on risks, widens the gap between what is socially desired and technically possible. One of the last piece of my talk, which I don't think I'll get to, but it really talks a little bit about the state of AI safety now, which I think is a bit stuck in technical terms, and we need to sort of course correct and learn from more socio-technical traditions, but also just from other disciplines more broadly. With ethics, there was more the postdoctoral work at AI Now, where we actually coined the accountability gap, which is about the risk that ethics, ethics efforts, while having a lot of good effects on raising awareness and building skills and reflective abilities in organizations and across organizations, can also serve as a way to widen the gap between those who develop and profit from AI and those who are most likely to suffer from it. And then the last gap is more about the push for policy. So we really see, and I think the current president has also, and also the president before him, I think in the US has also been arguing that the EU is writing too much digital policy. We have done quite a lot here. It's not impossible to keep track of all of them. But what you see is also, it creates a little bit more control over time, hopefully. But in the early days, it's the question whether the policy instruments are actually adding up to the effects that we want to, the kind of controls and effects we want to achieve with them. And of course, one of the sides or disadvantages is that it creates new forms of bureaucracy that might really also impact our ability to innovate and to move fast where we'd like to. Now, fast forward to 2025. There's a bit of a cynical slide, but then we can put that behind us, right? So we've seen that ethics sort of charter from the high-level expert group is rather vague. This is a European document, very high level. Google and other companies, corporates have recently basically abandoned their responsible AI principles. On the policy side, it's still, the AI Act has been heavily lobbied, and as a result is a bit narrow, and so a lot of especially human rights scholars and others are worried about that. Will it really have any teeth? This algorithm register is still voluntary, so there's many algorithms missing in it. And on the technical end, I already mentioned that there's a bit of currently a discussion about whether technical methods really do give us what we're hoping for. Okay, so that's very quickly the gaps. Let's talk about characteristics even quicker. I already mentioned that algorithmic risks, AI risks, are emergent system properties, so they arise from the interactions of technical and social components in a broader system. As a result, the AI risks are also understood, formalized, and experienced differently by different people in different contexts. So it's political, safety and risk is always political, intervention, including like coming up with new norms and assurances that we'd like to set and the interventions that are needed for that. And it's an integral challenge, so risk mitigation hinges on a very broad spectrum of practices, including design, use, oversight, and each requires norms for what is expected, as well as ongoing maintenance, management, to make sure that those norms are being met over time. And so we go back to those reflexes, right? Like I think a lot of the action that I was looking for myself going into my academic career early on already a little bit, which became more clear over time. It's like, how do you really integrate across so many different disciplines? Which is also really hard because it's not something you do within one lab. So how do you also, like, what piece of the puzzle are you bringing? And hopefully that will get a bit clearer where my lab is going. And so we've been going for 4 or 5 years, but this is really, I really see it as a long-term project. So with that, I want to give you a bit of some of the definitions and concepts that we've been working on, how we're integrating them, and then we can go towards the discussion. So one more time, safety is clearly an emergent property of systems, and this is Nancy Linson who says this, one of the pioneers in system safety, who has been studying the role of forms of software-based automation and control in safety-critical systems. Right, so that you can't really argue that a valve is safe, and she's said the same thing about software or models. Like you can argue that a model is safe. And here we find ourselves in 2025 with AI being the big technology and spread out over us as a big experiment with a big label of our model is safer than the other. Right? Of course, there's lots of work we can do at the level of the model, but can we argue that it's safe? Unison would be skeptical. And what I already mentioned is that I think there's lots of one of the key insights from me as a control systems engineer diving into system safety, which is really a sister discipline. So it wasn't that hard for me because it's really built on the same foundations as control theory, systems theory. And what we're finding is that it also has a lot to bring to discussions of algorithmic fairness and justice. So for instance, the project I mentioned in the energy system, where the issues are much more about distributing resources and burdens and benefits basically in the grid when we're starting to rely on algorithmic systems. So it's an operational definition. So this is the classical view. This is the transition from the early planes that had a direct perception and a direct control. We were hanging on the flaps. We're hanging on the valves of the engine, and now it's synthesized perception, indirect control, so what we need to think about is safety as a control problem. This is very natural also to control systems engineers and theorists like Jaime and his colleagues. And so what we really need to design for is not so much the AI, but it's basically the process. It's a process design challenge. And here we distinguish between the control process, so that's the process we want to control, like landing a plane, flying it from A to B, and the design of the controller. And then, of course, its interactions and the overall dynamics. And so for the layman terms, we have a few notions of control that I wanted to put on the table. And at the operational level, you could just take the nouns from the Oxford Dictionary, which says what's the control the ability to manage a machine, a vehicle, or a moving object as a noun. As a verb, is to determine the behavior or supervise the running of something. And then we have ends and means, and I would say that the ends are to ensure or prevent poor conditions and or outcomes in operational context. But also that the end is that we require some normative and substantive clarity on what that system behavior, what those dynamics and outcomes should look like or cannot look like. And the means are broadly about structuring the design and the use of the AI system through process. You want to go into to 101 on the first good step is to look at the process model. So that's understanding, okay, what are the goals and the constraints? What actions are available to a controller or maybe different controllers in a particular context? Actions that should ideally like give the ability to move towards the goal away from the constraint. What observability condition needs are there, so what kind of information is needed in real time, and this can be sort of measurements, but it can also be estimates or other quantities that are available through communication. And then the model and knowledge condition is more about, okay, what understanding of the control process is needed. And sometimes that's an operator that knows from experience and training how to navigate a complex process. Sometimes it's fully automated, and the system, the control system is a software-based system that has a model of the process, whether it's explicitly or implicitly programmed into it. Now, we understand control in aviation quite well. We trust it, right? So this is, I call this now, this is the public interest technology of the 50s and 60s. Like after the Second World War, we did not trust these planes yet. There were so many people dying from like in friendly situations. And this is in the context of the US context of the Department of Defense. At some point they said, okay, we don't really understand safety here. They started system safety programs back then, and then within 15 or 20 years we had like public interest planes, wonderful. And now we're all talking about public interest AI. So here you have my sort of 20-second elevator pitch for why we need system safety, for making sure that we don't only talk about harm, but we also have AI systems that will work. Oh, it will take 15 or 20 years, but okay. How do we bring that knowledge to other domains and new applications? Well, one thing we've done is to look at the social welfare context, because I care about it. We really need to take care of people who are in need, and in the Dutch context, this has been a bit of an issue. We've always had a good social safety net, but there were some issues around algorithmic systems and machine learning at the time. I was in my late PhD or postdoc, and I said, okay, this is actually something I'd like to learn more about. What we see in the social welfare context is that over time, actually, there's a lot of technology that has come in, and there's some scholars that distinguish between, back in the days, mostly street-level bureaucracy, so a bureaucrat sometimes even here in the Netherlands jump on a bike and go to families that were in need and that were potentially eligible for social welfare policies. And now we're living in a screen or a system-level bureaucracy where lots of those policies are also automated. There's so many decisions in the tax office that are in the Netherlands and many other places and many other countries, jurisdictions that are fully automated. So many letters that we have roughly 10 letters per citizen every year, and most of those are never signed by individuals, to give you a sense. And I also made the figure on the right of the citizen a bit blurry here, because as a result, we're not always in touch with people anymore from a government perspective. And so we rely on data about individuals, and increasingly about more and more data. And here we are also running into issues of the rule of law and actually the constitutional protection, making sure that the law of the state stays sort of limited and prevents difficult situations, which I think currently is a big topic, you can imagine. Okay, so like I said, we have control elsewhere too, right? But do we really have control in the social welfare context when we take this lens, social welfare? And here I want to introduce the running story of the childcare benefit scandal, which really was acknowledged more broadly around 2019, 2020, led to the fall of the government at the time. And the story goes as that tens of thousands of families, it really goes more towards 30 to 40,000 families, households, were falsely accused of committing some form of fraud related to childcare benefits. By now, we know that more than 2,000 children of families that were falsely accused have been removed from their homes due to issues of debt that sort of escalated. So this is really a huge tragedy. I call it, and some others call it, the biggest human rights scandal since the Second World War here in the Netherlands. And we know that algorithmic systems, machine learning, statistical models played quite a central role. There were a couple of those that were active in this social security and tax domain. Yeah, some of them were really like terrible from sort of a design perspective. 96% false positive rates, still being used by bureaucrats. Oftentimes the bureaucrats didn't know that these models were so bad. They didn't have access to it. These models, some of them were developed by commercial partners. And so that's sort of, the safety 101 in terms of like providing an operator with some insight into like how good this tool is and when or when not to use it. What we also know is it's not just about technology. So there's really a clear role for institutional racism, which was also acknowledged by the subsequent cabinet, which actually had the same political parties in it. So it was really the same cabinet, so to speak, with a few different new hats in it. Clear lack of human factors, as I just mentioned with the example. Both in the design but also in the governance, and then legal and bureaucratic overcomplexity. So our legal systems, our laws, policies for social welfare has become so complex that nobody understands it anymore. Let alone once you turn that into all kinds of process designs, whether it's human operated or automated, there are so many really emergent dynamics of people that are in a particular situation that nobody sees it coming. So it becomes highly unpredictable, not just for not just for citizens, but also for people working in this domain, which tells you about how sort of a mess we're in. And so the first PhD student I started working with, he's now wrapping up his dissertation. So now with him we really started to really focused on this problem, while also looking at wanting to develop a more socio-technical understanding of algorithmic systems, AI systems also. And so we looked into the role of risk indication models in this case to inform both the allocation of the welfare benefits, but on the other side also the sort of risk assessments to see whether someone might be committing fraud or might not be eligible. And these are typically different teams in different organizations, or sometimes in the same organization. But we also saw that some of those, the information that flows from these models also informs other kind of activities like debt counseling and other benefits, and that really created such a sort of web that we started calling a digital cage. I'll get to that first. But the kind of definition for this is that a complex socio-technical system, a public algorithmic system is a complex socio-technical system in which a machine-based system influences its real or virtual environment by automating, supporting, or augmenting decision-making in public administration. And so I mentioned this digital cage. So that another definition here. So you can imagine that people get stuck in a web of dependencies and all, but also organizations that start to come after them when they're pushed into debt because of false, in the scandal, false accusations. And that reminds us, or it reminded these scholars, Peters and Whitlock, also Dutch scholars, of the iron cage that Max Weber sort of coined and conceptualized. And so this is the digital version of an iron cage. They call it a digital cage. It's a highly disciplining infrastructure that rationalizes the execution of tasks through information architecture and algorithms instead of through Weberian rules and procedures. So I won't go into details here, but you can imagine Weberian rules has something to do with allowing discretion, allowing understanding the particular needs of a particular person in a particular situation. And you can imagine once you start to automate things, or formalize things, whether it's through actual software-based automation or through other forms of formalization, you sort of lose visibility to have discretion for a bureaucrat, or to have the ability for a citizen to contest or dissent decisions, and as a result, yeah, you might, especially with algorithms and software and automation, you might also really amplify issues that start small into really big scandals, as we see. All right, so with Sam, we started working with a master's student, Maurits, who now just recently started his PhD, and yeah, we wrote this piece based on his thesis. This piece is still under review, but I can share it with people who are interested. But all of it is in his thesis also, where we really started to bring system safety, but also the more control theoretic part of it, to understand how these issues emerge. And here on the right, we do see sort of operational context, which is more than just the sort of immediate operations. You know, you don't have to read it in detail, but here you see the tax office. They have different teams, and they were using what's called a fraud signal facility. So there was this idea of like keeping track of signals of potential fraud. And that information was then gathered centrally, and was then also fed to different teams that were doing, were sort of managing different parts of either the benefits or the taxes of particular households or businesses. And there were three key sort of really canonical control issues that we found through doing document-based analysis, because there's lots of public information available. So in a way, it's not new, but it's really a new interpretation that also allows us to then say, hey, like if you would want to design this differently, perhaps you could, make these kinds of interventions. We're not there yet with this particular context, because it's much more about, it's more of a study, an analysis, system analysis of this particular scandal. Control issues we found were canonical in the sense that I think many control engineers and theorists will probably recognize this. So the first is the lack of coordination across controllers. It's this problem of overlap. If you have different controllers or different people trying to control the same thing, that very easily goes wrong. It's in control theory, we sometimes call it decentralized control. It's one of the hardest problems in control theory. But it happens a lot in practice. You can imagine like a kid having two parents pushing it in a different direction and getting very frustrated. That's also a form of overlap. The second problem is about runaway feedback loops. I think those of you interested in like sort of the role of machine learning and how bias can build up over time have probably heard of this before, where if you have a particular form of bias in a particular process and you start bringing machine learning to it and you learn from historical data, it can be that the biases can reinforce themselves over time. If you start sending people in one direction, they collect more data and find more evidence there, or find the same more signal there, you retrain your system. And that's what happened here as well. And the last one is misaligned mental models. So this is more about, okay, I've designed a particular fraud signaling facility. This is basically an algorithm that spits out some information, a risk score about individuals. But how is that then sort of by design how does it go from a designer to a user, or from one user to another user? And there were like sometimes really subtle misinterpretations and miscommunications about what you cannot or should not do with this information. Okay, well, the other part of the story, I think, which is quite sort of representative of a lot of the work we do, is that, methodologically and conceptually we're integrating different aspects here. So what was very central to this analysis is a more canonical method called system theoretic process analysis. So I mentioned controls is really about designing a process. analyzing it, but then also designing, using your analysis to redesign a process, whether it's at the level of the technology, at the use, or maybe the management, or broader institutional controls. STPA is really a good starting point for that. But we also find that, you know, in system safety, the work that comes out of Levison's lab at MIT, they do also look at the more organizational and the broader factors, and I think STPA has a good handle on like bringing those in. But that also sort of open ground for like further development of making, like helping people to better map, you know, processes and organizations, and understanding also the more normative and political factors. And so that's sort of like one of the directions or of integrate, like forms of integration that we're doing, because our students are also trained to be to understand not just technical design, but also what we call institutional design. So how to design good sort of norms and instruments and processes. Okay, so I'm at half an hour now, roughly. So I think I go for another 10 minutes, maybe. Is that okay? I'm in? Yeah? Okay. So here we have a second notion of control I wanted to put on the table. So this is more about control in or between other processes. So the definition is sort of similar, but I would also add another definition of control, which is the power to influence and or direct people's behavior or the course of events. Right, so it becomes a little bit more social and human, so to speak, right? Because we're sometimes talking here about like teams or managers that are trying to control, making sure that their employees are doing the things correctly or preventing mistakes and hazardous situations from emerging. In terms of the ends, also similar, so ensuring or preventing poor conditions, requiring normative and substantive clarity about what are the kinds of dynamics that we want at the level of a team or a level of a manager that's overseeing a team, but also for the now for the adjacent supporting processes and actors. And the means here, in system safety, we talk about references and measurements, so that's very much a sort of control theoretic perspective. But we need to understand, okay, what reference is a manager putting on the actual operational process in which they're using an algorithm or an AI, what are the kinds of protocols, instructions, and then the measurements is more about being able to check and verify whether those instructions are being followed up, whether they're leading to the right kind of outcomes. So very simple, so to speak, I think pretty intuitive, I hope. And so what we're talking about here are control structures. So we've talked about the dynamics between a controller and a process that's being controlled. And now we're sort of taking a step back, zooming out, and we're seeing basically the area of system operations. So we need people managing operations, right? They might not be in the operational process themselves, but they're managers. And I just gave this example of a manager having instructions and protocols that need to be followed. We distinguish then between system operations and system development. So here we have things like the maintenance of this process and the particular AI or algorithmic components within it. We often see product management as playing an important role with this in the industry. And then we have, of course, implementation, product system development. These are just a few, there can be many others, right? And really abstracting away a lot of potential other processes and actors that come into play when we're developing complex systems. I think what's also important, what I'm sort of adding here, is the system dependency or the infrastructural dependency, right? So there's more and more, especially with AI, we're seeing that it's not just an input or an integral part of the AI and the controller, so to speak, that is used in an operational context, but it's also more and more forming through, especially through LLMs and in their applications, and the integration of these models in all kinds of professional environments. It's starting to be really a core dependency for other processes as well. Eventually we have company management or organizational management. We can go up with the control hierarchy. There's many more layers we could add here. And these are all actors that are contributing to norms that need to be ideally imposed and trickle down, whether this is a very clear sort of standards for AI, or these are measures of transparency about like what systems are you using, what capabilities are you using, what dependencies do you have. But in the end, the same logic of control can also be applied to these different interfaces, these different arrows up and down can be seen as references and measurement channels, so to speak. And through that, you can also start to understand, okay, if we have a good understanding of what the role of a particular standard, not so much on the AI, but let's say there's standards for how you develop or how you evaluate a particular system. We really understand that well, it becomes a control problem. And hopefully you can use systems analysis to then try to understand, okay, if something goes wrong in how we validate a particular technology before we put it into a plane, then how might that trickle down, right? That we have developed these kinds of control mechanisms and sort of subsequent understanding of what interventions are needed when something is off or might be off somewhere. And I think it's good to mention here that it's not just about like formal control mechanisms that are about like, I have a very clear sort of understanding of what I'm measuring, or perhaps you do, but it can also really be social, it can also be very cultural. So we know that, you can do all the formal bits perfectly right, but if there's not a culture within an organization that's really responsible for safety critical systems and their outcomes, if someone is noticing an issue with a plane, with a part of a plane, and it's swept under the rug by a company, which is something that more or less has happened with Boeing as well. We don't have time to go into it, but like culture is really critical there, right? And so in a way, you can also think of culture. There's some parts of culture that we really should control for. There should always be, in an aviation company, there should always be space to discuss potential issues, even if they're not there. I think an important note, and the same actually holds also for democracies and making sure that democracies work, unfortunately. So then now governance, that's the word I think that most of us hear. I think we hear a lot about, also in the context of trust and AI systems, safety. And here, I think looking at the definitions is also helpful because it says it's a broader definition, which says like conduct policy, conduct action and affairs can be of a state or an organization. It can be to control, to influence, to regulate. And it depends on what is written in applicable laws and policies. It does not need to be clear yet, normatively or substantively. You can have a governance scheme that someone said, okay, let's start doing this. Right, so I want to distinguish here between control and governance as a way to say, okay, control, ideally we should call something a control problem if we sort of figured it out or if we have a very clear understanding of what we're aiming for and how we get there. And within controls you still also have lots of normative issues. I'm not saying it's not normative anymore, but I think it's an important distinction to at least to understand the current landscape of AI governance, which feels, at least for me and many other people, to be all over the place. And in a way also, it's very political. There's really big stakes, of course. So there's lots of lobbying and influence from all kinds of directions. And there are many different philosophies, regimes, and approaches. And that means it's also, it's a struggle. So with the last 5 minutes, if we go back to the childcare benefit scandal, this notion of governance but also control structures and the sort of associated lessons from system safety have been really fruitful to gather, to reflect on, and have led also to, they have informed the setup or the installation of a new algorithm watchdog, an oversight body that is tasked with identifying and analyzing high-level algorithmic and AI risks and to share knowledge to other, basically to society, to politicians, to parliament, etc. To strengthen the collaboration because oversight is really a big task. It's not, they're not as one coordinator, as one oversight body, they're not going to oversee every sector. They're going to be working together with other oversight bodies that know a lot more about the energy sector or the healthcare sector. And then it's about promoting guidance and creating an overall view in relevant frameworks. And they're also struggling with so many frameworks and tools emerging. But what you see here on the right is a collaboration we have with a master's student where we really map these control structures for the particular social welfare domain that I've also been talking about today. And that brings into view, well, this is not the operational part. The operational part is abstracted away here, but these are all the other actors, including other oversight bodies, participatory bodies like an ombudsman, Institute for Human Rights, interest groups like Amnesty, and then at the bottom you see the sort of operational piece, the agencies that are actually doing the work, and also the dependency, because social welfare is not just executed at the national level, but there's also a lot of pieces that are executed by municipalities. So for them to really understand, okay, like how do algorithms then impact this really complex operational domain that is also so many different actors that have something to say or something to bring to how these processes should work, how we should deal with risks in them, is a really major task, and this will take years. But sort of mapping these control structures, mapping the different actors, their different roles and interdependencies, is a really valuable start. And we've also, as you saw in the previous slide, we've also combined it with a more operational understanding of these risks, and we're sort of slowly working towards, okay, now that we see that these tools have value, like how can we actually bring them to practice? Because they rely on a lot of sort of methodological, conceptual expertise that we have in our team and with our students. But hopefully, some of these methods, control theoretic risk methods, you could call them system theoretic risk methods, need to of course land in practice, and that's I think a big challenge for the next 5 years, maybe longer, of my lab. But I'm hopeful because we have a good relationship, and they've already been quite eager to sort of pick up ideas and concepts and methods here and there. Okay, so I think maybe to sort of end with Inigo, which is another PhD that's wrapping up currently, and he's just really cracked a big piece of his PhD, and I think I just realized before the talk that it really has to do with this interaction between governance and control, or let's say, like as we are figuring out, like we have a lot of governance schemes, and we need to try them and learn from them. We have a lot of self-regulation. Ideally, companies learn how to regulate themselves, but we also know that they love to self-regulate and prevent other forms of regulation. So what part of the governance puzzle needs to be in the hands of public oversight bodies, and what piece can we trust companies to do, but also markets and sort of constellations of companies to do. And as we're figuring it out, more and more, our standards, our norms crystallize, our ideas of assurances that we might demand or expect or demand as we started out with will become clearer. But of course, this is an ongoing struggle, I would say. This is a long-term project. But the key thing is that, as we're getting clearer, of course, we can abstract away some of this complexity into whether it's a norm or a mechanism or a technological fix or requirement. And it's this notion of abstraction in a socio-technical environment that's been very central to some of the work we've done in the last years. And this is really led by Inigo de Troya. And his work is now coming out, so he's exploring especially what can go wrong when we're abstracting, not just at the level of, let's say, an AI model trying to represent some natural phenomena, but also in between actors, or as we're sort of formalizing notions of governance and putting those into place. And so, to make it a bit concrete, we were, for instance, looking at this algorithm register, right? So the register should sort of list all the algorithms that are used by public organizations. But ideally, once those algorithms are in there, you can also learn something about what they're used for, what the risks are, how they're dealing with the risks. And this is really like a game of abstraction, and most companies or even public organizations, they don't want to put their systems in there, even if they're like mundane systems. It's just, it creates transparency, it creates, risks for administrators. So it's really a political issue actually, but it's very important. So watch out for Inigo's work. It will come out in the Fairness, Accountability and Transparency conference in Athens, Greece, this June, next month. But yeah, I just wanted to have that mentioned, and with that, I think it's a good time to go to the last slide and have some discussion.
All right, wonderful.
Thank you very much.
Great. So, let's see. I think maybe since the communication is going to be a little bit indirect, maybe we'll take so let Jaime be rules proxy and manage the question answering, and I'm just going to try to orient the laptop roughly towards whoever's asking the question. All right. Any thoughts? This is, I'm sure a lot of this is new, or familiar to many of us here. There's certainly connections. I'd love to see folks getting out of their comfort zone and asking some questions. Go for it. Let's see if you run down.
Hello.
Cool. I'm not sure. Are you able to see?
Can you hear me?
And can you hear us?
Yeah.
Oh, you're frozen for a second.
Yeah,
Hi, I'm
I can hear
Hadas.
you.
Yeah. You can kind of see me waving my hand. Help. Maybe not.
Oh.
Oh.
Yeah, I can see you.
Is it coming?
Yeah.
Yeah. Okay, great.
I don't know if I can hear.
Okay. Well, I have a microphone, which may or may not help you or not. We don't know. So.
It's okay, yeah.
So maybe not quite out of my comfort zone, unfortunately. So but I was intrigued. At the beginning, you had the three reflexes, and you had safety, you had ethics, you had, I think, governance. Oh, I think governance. But I was going to go for the first one. I forget how you phrase it exactly, but you said that we don't quite have the tools. And I was wondering whether you can elaborate on that, because I'm fascinated by that.
Let's see. Did you hear the question?
Yeah.
Did you hear the question fully, Roel? Do you want
Yes.
to repeat it? You're good.
Yes, I did hear it. Yeah. And let me see. I think there was this one piece that I added. So this has to do with the more sociotechnical gap and the issue that if you push, we might widen the gap between what is socially desirable and technically feasible. And I think the best way to explain that, because in the way I started worrying about this was literally at Berkeley, being in a cubicle with like half of us being people like me and Jaime, like control systems engineers, always focused on safety, some notion of safety, right? And then people from Stuart Russell's group that were starting to talk about AI safety. Well, this is 2015, it's 10 years ago, and you can imagine, I don't know how much Jaime and his people have talked today, but as you've heard me talk, it's a very different idea of safety. And but then recently, there's been a couple of AI safety summits, so AI safety became really central to these global AI governance conversations, and it started off really, in the UK with Sunak, who invited, Benjos you're seeing here in the background, also like the tech CEOs, and we're almost not like scholars or other actual safety engineers. Very few of them were there, let alone like NGOs and other bodies that would sort of represent like people that are in need of some form of safety for AI. But eventually AI safety became also the topic of the Seoul Summit And then, this February we had now it's called the AI Action Summit, so it's become a little bit more broader conversation. But within that, or in preparation for that, Benjio actually led a big report, International AI Safety Report, and it had 96 experts on it. 30 of them were nominated by the OECD, the EU, and the UN. So this is like really, institutionally supported effort. And if you look at the report itself, it has really a focus on technical safety methods. So they don't even look at any other methods, which is really interesting because after studying safety for so long, even before I looked at system safety, just like why would you only look at the issues of AI risk through a technical lens or like in terms of mitigation? It just doesn't make sense to me. Of course there is a role for technical methods, but why is there such a strong focus on it? So that's really strange. But then a few people I know that were on this in this group of 96 experts that also felt the same and that were also trying to sort of input ideas and information. And then of course there was also a lot of actual evaluation of the technical risk methods. And what you see in the conclusions is that the actual conclusion is that across all considered technical methods, there are significant limitations. And I'm not saying per se that if they would have looked more broadly that they wouldn't have found significant limitations. But I do see, and this is what I sort of reflect on in this policy brief, I do see a lot of, like traps, like common mistakes in thinking about safety that you see it in the report. But also sort of common challenges that are emerging in the conclusions. So that's a good, in a way it's also a healthy, right? So this is a new community. I think it's still technically focused, it should be broader. But it's also learning that, there are lessons to be pulled back from history, so to speak. These are the points that I'm developing in the report. So I guess I'll stop there because this is largely just looking at system safety, the history, and a lot of the work that Nancy Leveson and others have done.
So perhaps let me see if I can put myself into your view. I guess I'm in your view. Perhaps following along these very lines, I think that's something that I find very attractive in the way that you're looking at these problems is that. And I remember we had a discussion, and I'm not sure that at the start I was really understanding what you meant, because to me the terminology is it gets confusing when saying technical safety or technical methods for safety or aspects of safety versus the broader sort of socio-technical view of the problem. Something that I find very appealing about the way that you focus on the problem is that you're looking at this broader class of questions and of possible vulnerabilities and harm and so on that are not always just something you can easily write down in math. But then you take a very systematic approach. What maybe I might call it in my use of the word very technical approach to understanding
absolutely,
and to looking for solutions, right? And so something that I wonder is there, how do you think about really sort of operationalizing this question, and is there a way to bring our tools together and to be able to provide some strong, if not guarantees or assurances, strong analytical structure to understand this much broader problem without accidentally sort of misabstracting it and losing some of the key essence of the problem in the process of trying to tackle it.
Yeah, I think that's I would say yes in terms of developing a broader analytical lens, conceptual basis, methodological approach. I think this has been done for a longer time. It's really one of the reasons why we now have a good handle on safety. It's not safety in software systems or software-heavy systems, so to speak. At the same time, yeah, or maybe before I go further, like I think the way that the word technical is used, it also requires maybe a little bit of, I mean, maybe even the way I reflect and use it requires some revision, in the sense that I think technical is often also used by politicians and policymakers as things like, okay, that we have experts for that, right? But that doesn't mean that whatever analytical approach or design approach like is only about technical components, right? Whereas what I'm saying here is, well, safety is, that's another use of the word technical, is that there are technical components, there are social components or actors or people and their interactions. And so perhaps, you know, a lot of the issues with the technical AI safety community are that they are, maybe not necessarily, let's not call it stuck in technical terms, but they're like, you know, they're looking at the model. They want to address things at the level of the model, right? So I think your appeal to a broader systems approach, I think it's also just very necessary. I think it's reflected in the work you've been doing recently with your lab as well. At the same time, yeah, when you make things, when you have an analytical approach like that, like for instance we applied to the child care benefit scandal, it doesn't mean that now suddenly you have a way to sort of abstract away things, to sort of think that where we have very clear approaches for everything. If anything, maybe part of it is really like requirements for technical components or how you use them, but other might be more procedural, like if you're building a highly automated welfare system, well, you really will need to have like teams where people from different parts of the organizations are coming together to sort of test and evaluate and discuss, you know, edge cases all the time, because you might, you know, you'll have these kinds of standards. Is that yeah, you could still call it technical, I guess, right? But it's much more realistic. It's not always going to be the most efficient way to do things, but yeah, that's, if we want safety and trust, that's what we need. Slow things down here and there.
Awesome. All right. Any other thoughts? Questions? I guess complaints are probably allowed as well.
Of course, please do.
Encouraged.
Feel free to disagree or just to tell me that I need to start over again.
Right. Well, if not, well, let's thank Roel once again.